Let's start. Nice to meet you all. My name is, first of all, we are here to talk about how to orchestrate infrastructure as code resources just to make it more scalable. The idea of this talk is just to speak about my experiences in the past. I've been working in, this is my 8th company in the row, so I've seen some big challenges in the past or some things that I learned. And I wanted to share it with you because probably for you, people who need to adopt infrastructure as code because of the company, the company that you are working might tell you that, hey, we need to do this just to apply to a compliance, or because you care about the infrastructure that you are serving or the things that you are serving to your clients. First of all, you don't care about myself. My name is Matias. I came from the other part of the world. I'm Argentinian, but nowadays living in Barcelona for about 3 years. I do a lot of stuff. I play a lot with cloud providers. I do a lot of bug bounty. I work at security at the moment in Mews. Mews is the PMS. It's a PMS. PMS is called a property management solution or system. Essentially, it's a SaaS for hotels. For whenever they want to manage the entire property, you can go to Mews and or either manage invoices for your clients, or manage the booking, or manage everything that is related to a hotel. Essentially, it's that, but within a lot of things within it. So, what are we here for? First of all, I'll try to do some kind of introduction for the ones that doesn't know anything about what infrastructure as code is. This talk is not going to be super technical as the two before. I know the second one, I don't know, Martin was telling something about it was not that technical. This is going to be lower, but at least I hope it's going to be funnier, or I don't know, sorry. But the thing is, the thing is I wanted just to make a point on some of the things that were relevant to me. So, in my past, I want to show some of the advantages of using it to manage infrastructure being a developer. Then, the elephant in the room is, why is it so hard? Coming from a DevOps background or a security background, it's really hard sometimes. And whenever you came to a company, they have everything already set it up, and it's really a mess. So there are some problems about adopting it. And then we'll try to go to some tips and best practices whenever you're trying to do it. So let's get into it. First of all, whenever you're doing something, I think I missed a slide. Well, whenever you're doing something, by default, you are defining resources, and then we're trying to apply those resources in your infrastructure. Essentially, what I wanted to show over here, that whenever you are creating something, by default, it's taking the program, whether if it's Pulumi or if it's Terraform, it's taking the default identity that you are managing on the computer that you are running. If it's your computer, it's going to be your Azure, AWS, Google Cloud identity that is already authenticated to the cloud, or to the vCenter, or to the Kubernetes cluster that you are trying to manage. And if it's on a GitHub runner or whatever, it's going to take the identity that you specify at that point. So it's super useful, and as a really good thing about managing it as a developer is that you can essentially copy the exact same procedures that you are applying on your own computer within the cloud. So essentially, here at Mews, we are using Pulumi for defining our own infrastructure. So a developer could go on its own computer and put Pulumi up. The infrastructure is going to be created if it's applicable to the cluster that he's managing, and he could potentially see all that infra for his own application being deployed on a local cluster. If it's on production, essentially it's going to happen the same, but within bigger chunks of CPUs and such. So, essentially, why do we need to manage infrastructure as code? I try to point out as many logos or applications because I didn't know the crowd that we are going to have over here. But essentially, sorry, this slide was supposed to be before the other one. But essentially, you are that developer, you are writing code. Whenever that code reaches to your your code source. That code source is going to trigger an action to one of those, I call them factories, in a way, just CI/CD tools that will take that information from the manifest that you are specifying and will create the resources in the cloud or on-premise or whatever you want to do it. What is it for? Just to have scalability, because if you want to scale and if you want to, let's say that you are, for example, I work in a company that we manage tons of seasonal events, for example, Black Friday, and whenever there was the Black Friday season, just to scale up the application, it was not something that a man could go to AWS or to Azure and increase manually the amount of resources that we were serving. Then for collaboration, because you have everything, you have traceability on the things that you're doing, and you can see exactly a one-to-one mapping of what you are impacting on your cloud provider or whatever, and in the code that you have specified. Auditability for various reasons, it's much easier to audit which are the type of resources that you are deploying to the cloud and just to have a quick glance of the things that you have. For automation, automation is a key, and this is more or less like 100% of what I'm going to be talking about is automation and a little bit of security. As well, for security, there are many tools embedded on the automation part that you can run on top of those things that you are defining. So whenever you want to create something, you can block that request instead of going through the cloud, and that it's going to block that apply into the cloud provider. So if you are introducing some sort of vulnerability or whatever, that could be blocked instead of creating an issue within your infra. And for consistency as well. So the thing is, which are the hardest parts of adopting it? First of all is the complexity. So whenever you are trying to define something, it's not as copy and paste. You can go to each of the cloud providers and try to, to each of the IaC tool providers. For example, if you go to Terraform, you can go to each of the templates, try to copy that out, and it's going to be, it's going to run, but it's not that straightforward. You need to apply a lot of things, and it's not that easy. And whenever you start doing those things from scratch, you start lacking a lot of standardization. When for example, in my case, I joined Mews, and Mews, as many other companies, start from ground, and we at the very beginning, there was one or two guys that were defining all this infrastructure. They did their best, but now it's much easier, as I think the talk before, they were also mentioning that they were decoupling from a monolith. We are doing more or less the same in Mews. So it's really a complexity that most of the companies, whenever they hit to a particular growth limit, they need to decouple some of the services and try to standardize. So the other thing is, whenever you are starting from scratch, most of the people came from a developer background, and they might know or might not know about the infrastructure designs. So for example, coming from a security background, let's say that you want to serve an application that doesn't need to be contacting some others. You want to put them on different type of namespaces on a Kubernetes cluster, because if not, those pods or the services that you are going to be serving on that Kubernetes cluster are going to be easy reachable from one to the other. And well, also like the last problem is, whenever you try or you say that you want to start with this, the big problem is that there are a lot of procedures already in place. So in many cases, it could be like a shady bash script that is running your entire application within make app or make deploy, and it's running a lot of lines of bash code under the hood, which is not the best approach if you want to do things like this. So, which is like the very first thing that you need to do. Like, if you are starting, you need to choose a tool, an environment, something that is going to help you. So I tried, whenever I was trying to prepare this first slide, I was trying to think about, like, okay, 3 types of scenarios. First of all, if you are like, well, on this side, if you are super attached to a particular cloud provider, you probably, it might be better for you if, depending on the contract that you have or whatever, just to have the common tool that they already offer. So, for example, in the case of Google Cloud, they have Cloud Build, which is, it's pretty decent. I used it in the past, and you can do a lot of things because they have like kind of a free tier for most of the accounts that they provide that is sufficient enough. Then if you pretend to grow a lot, for example, in many cases, companies need to create different type of resources in different type of cloud providers. So a tool more on the other side, for example, in the case of Terraform or Pulumi might be best because both of them, they can support different type of cloud providers. The thing is, the approach that you are going to take. If you are like, if you have a product that is already big enough and you need to templatize what you want to do, perhaps Terraform might be at least from my point of view, the best solution because it's kind of what I say is a snapshot of the infrastructure that you already have. So you can go to your infra, create and try to import all that infrastructure and apply it to your templates. If you want more flexibility and also just to call the resources that you are defining from your application, you could do it within Pulumi. Pulumi can be written in the same code or most probably in the same code that your application is going to be running. So let's say that you want to add some sort of logic to that app creation, you can do it within Pulumi because that application that you're going to be serving could know and could interact directly within the Pulumi classes that you're going to be defining. So more or less, that's the approach that I will try to recommend anyone that it didn't start within adoption of infrastructure as code and need to start. After that, it comes this other part. Like probably you'll have something like this. I try to make it as simple as possible, not knowing who was going to be over here. But you need to define your release process. Whenever you are building an application, you want to create an artifact that you want to deploy directly to your cloud environment. So whenever you are creating that new release, you want to create a pull request. If all of the check pass, you are going to create a release and merge it into test. And whenever all the testing is okay, you want to create another pull request from testing to prod just to merge all those changes. And once all that's done, you want to promote that test environment to production, and that's it. There are a lot of caveats and things that can be done within the middle, but I try to be as simplistic as possible. But this is more or less the thing that you want to be considering if you want to do it. And another thing that I consider like super, I think this is the most important slide from all the presentation. The thing is, whenever I came to many companies, people try to do infrastructure as code for the entire application, for creating a Kubernetes cluster, for managing all of the cloud resources, but also for managing the application infrastructure. And that's, from my point of view, that's not the best approach. Because if you want, like, give the responsibility of the cloud resources to DevOps engineer, in the case you have them and you have a team dedicated to that, and leave the application logic and the application infrastructure to the DevOps engineer that are particularly for each of the teams. So what would you get as a direct benefit of doing that? That if you have an application infrastructure as code definition, you could also have, for example, in the case of Mews, we have our own internal team, the tooling team, that it's building up an internal SDK for our developers. So it's something, obviously, that perhaps a company a size of Mews can have, or I don't know. Maybe on some others you can share code more easily because you can standardize the way you access those resources that you have already created. Also, you standardize deployments, you facilitate productivity and consistency, and for security and for ensuring that that you meet compliance requirements, it's easier because there is only one implementation for all of the things that you are going to be deploying to your cloud environment. For the cloud environment, on the other side, you can have, as I was saying, like a full standard for your whole company that it's going to be used by all your environment or all your developer teams. That is gonna, and you can spot out application on ownership based on that type of resource because you have it already done within the different infrastructure that you already have defined. So, on another side, I want to give you all some tricks and tips, about how to implement infrastructure as code, at least on a better way. Probably everyone over here or might be a developer or might know a lot of things about Git. I don't know if all of you, like just as a hands up, have any of you used Git submodules in the past? Does anyone use Git submodules? Yes. Well, okay. The thing is about Git, it's super dumb, perhaps the approach. But the thing is, like on many of those times, whenever you are defining infrastructure as code, you keep repeating a same pattern on the things that you are deploying on your own infrastructure or on your own application. So by having everything like completely standardized will be much better. So instead of repeating a same pattern on each of the applications or microservice that you are defining, for example, in the case of project A, I am adding a new change and therefore perhaps or changing the infra or changing the application, I might be, for example, modifying every time the infra and like in 2 years' time of a particular project, that could be a complete spaghetti code. So it will be nonsense like one project to the other one because they won't be traceable. In the case of what I am trying to propose is just to use Git submodules as your main repository of all of the infrastructure of all of your applications. In our case, for example, we can define within Pulumi one repository, have everything already within that repo, and then you can branch as many times as you want, depending on the type of applications that you will have. Those branches will be the ones that are going to be pointing to your app, so your app will know how to implement the infrastructure whenever they want to deploy something. The other cool approach about that is that you could get rid of a lot of checks on the infrastructure that you are defining. You probably know whenever you are trying to do a pull request, there might be like hundreds, if not like 50 or whatever number of checks that infra is going to be, or that code is going to be running. The thing is, on some of those times, like or DevOps engineers or developers that are managing the GitHub repository, they might have or a lack of knowledge or they don't care that they might be spawning up like several times different type of jobs, because in the case of GitHub Actions, they might trigger an action in a case of a push event. So whenever there is a push event on a master branch, trigger this execution. That's not a really good approach, because whenever there is a push to a master branch, if you don't have branch protection rules in place or whatever, that could lead to triggering a pipeline whenever there was a modification in a part of a code that you don't want to be tracing off, and creating release and consuming time, and therefore like consuming resources when you don't want. What I would say, like, if you separate those two repositories, you can have your checks on one side, do all the checks on that repository, and your repo will be like checks free when it comes to security checks, you know, or like infrastructure as code checks. If you want to meta policy, all those checks that will be fetched for that particular policy that you need to apply are only going to be checked on the repository itself, not on your code-based repo. Then it will be easier in another way, for a DevOps team, let's say that you have a tooling team, as we do, just to release new versions of a new resource. Let's say that, for example, everyone nowadays is talking about AI. So if there is a cloud resource related to AI that you want to adopt as an application resource of your microservice or your application, or a cache DB or a SQL DB or whatever, that's a cloud resource that you want to have on your own app. That resource could be added easily on the future, because your tooling team might not introduce that feature right now. They might introduce it in the future. So that could be easily done by pulling down some of the changes that the tooling team is applying into master. So now you will have that feature, and you can implement that resource that easy, just because referencing a particular class that was already defined. So after all this, the conclusions about everything is like, decoupling, at least from my point of view, it makes it much more easier, because you can have all the application on one side. We already covered all of this, but your application will be lighter. You will have less checks. So it will be much easier, at least from my point of view, to developers to adopt. Also, the tooling that you are going to be adopting, it's really a key. It will much depend on the tooling and also the environment that you are going to be deploying everything. So if you are running on Pulumi or Terraform, probably and also if you don't rely that much on cloud services, but on, for example, in the case that you are doing something within Kubernetes, you can do it more or less, because I already tried, you can do it more or less seamlessly within the cloud or your own computer, and spawn up all your application logic by replicating what is being done in your cloud environment. Then, as we were saying before, new features at a merge of a distance, because you can, by merging new features that a particular tooling team might be adding to that repository, you can pull in some new features that they might be trying out, and have that as a default on your resources that you can implement. And also, you can isolate, because it's much easier to update the infra and also to trace down who's an owner of a particular application whenever you have everything into one place. And you, for example, you can trace down within code owners file who's the owner or who's the team behind a certain type of application, which makes, at least for security folks, more easy to spawn who's behind an application. And that's it. If you want, I have a personal blog. If anyone wants to read more about it, I'm talking a lot about bug bounty, or like some weeks ago, I made a talk about how to do some bug bounty recon on Kubernetes clusters, and also GitHub Actions, which, at least for me, was super fun to do. And also, Mews has their own developers portal, which it's pretty neat. They have really good content. So I recommend everyone just to go to the Mews developers portal, just for all type of knowledge. There are many posts that I can recommend you afterwards. I didn't add it at the end. Probably you might not be the right target. I was talking to some of you, but also Mews is listed, not publicly, but I am managing the HackerOne program that we have. So if anyone is interested in coming to us and trying to hack us, please, you can come to me after the meeting, and we can discuss if I can add you also to the bug bounty program that we are managing. That was it.